Welcome, welcome, welcome. Good evening, good morning, good afternoon from anywhere in the world you can hear me. Please, I would like you to respond. This is going to be a very interactive session. Welcome to KodeHauz webinar series. My name is Ayo, and I have here with me Iechi Achom and Lucy Uwoboye. Very soon we'll be getting right into the answer, and I know you're ready with your laptops, with your devices. You're ready to just get right in. Yes, but before we get in, I would like to just, hear from one or two persons. How are you doing? Where are you tuning in from? So please use the chat. Everybody will not be speaking, so we'll be using our chat a lot. So please go right to your chat. Tell us where you're joining us from and give me your best emoji. Happy new month. Welcome to the month of August. Quickly, I'm going to pick two persons. And before I do that, ensure that if you're not picked, do not unmute your mic until you're told to do so. And whenever you want to ask a question or you have something to say, always raise your hand. Okay, so the first person I would be calling this evening, quickly, Chisom Amadi. Hi, Chisom. Just tell us your name, where you're tuning in from, and how you feel right now. Okay, quickly, Chisom, can we have you? All right. So if Chisom cannot speak, we'll go for somebody else. Hi, Linaya. Linaya, can you hear me? Can everyone hear me?
Yeah.
Hi, good evening from Lagos, Nigeria. Can you tell us your name, where you're tuning in from?
I'm from the UK, attending University of Buckingham.
Okay.
Yes.
All right. It's so good to hear from you. Okay, so one more person. I'll be calling one more person. Etubo Judith. Hi, can you hear me? Your name and where you're tuning in from.
Um, Good evening,
Hi.
everyone. My name is Etube Chidi. Hope you can hear me.
Yes, I can hear you.
Okay, I'm speaking all the way from River State, Port Harcourt.
River State, Port Harcourt, Nigeria. Welcome. So welcome once again. So quickly, I'll be handing over to my co-host here, Iechi Hachom. Iechi, can you hear me? All right.
Yes, I can hear you. Good evening, Imole, and good evening, everyone. Welcome. Imole, can you hear me?
Yes, I can hear you. Please go ahead.
Okay, so good evening, everyone, and welcome to the KodeHauz 10th anniversary webinar series. It is a time where we want to sit at the feet of very seasoned speakers, very seasoned personalities in the tech ecosystem, in the tech space, to be able to draw from their wealth of knowledge. So that is what we are going to be doing today. And it is also a part of the KodeHauz 10th anniversary celebration. KodeHauz is 10 this year, and we want to celebrate it with a bang. So this is part of the celebration. So quickly, I'm going to be reading out the introducing our speaker for today in person of Dr. Philip Obiora. So stay tuned as you learn a little bit about the speaker. So Dr. Philip Obiora is a machine learning engineer, data scientist, and AI researcher with extensive experience in artificial intelligence, machine learning, natural language processing, cloud computing, and data science. He currently serves as a learning development coach in computing at the University of Buckingham, United Kingdom, where he supports the development of future computing professionals. He's a passionate advocate for technology education and community development. Dr. Obiora is the co-organizer of Pi Data Melting Canis, a non-focus affiliated community, and the lead of Google Developer Group GDG Cloud Port Harcourt. Now, through these roles, he has organized numerous technical events, workshops, and conferences, empowering thousands of developers and technology enthusiasts across Africa and the United Kingdom. His academic credentials include a PhD in computer science from the University of Port Harcourt, an MSc in applied data science with distinction from the University of Buckingham, and an MSc in computer science also from the University of Port Harcourt. He's also an Oracle certified professional, a Google Explorer ML facilitator, and a member of the British Computer Society, BCS. Dr. Obiara's research focuses on machine learning, generative AI, retrieval augmented generation RAG, natural language processing, and sentiment analysis, with several published works exploring advanced AI techniques and their practical applications. He's passionate about bridging the gap between the cutting-edge AI research and real-world solutions that drive innovation and business transformation. At KodeHauz 10th anniversary webinar series, Dr. Philip Obiora will be speaking on building multimodal RAG systems, inspecting rich documents and video with Gemini. In this hands-on session, participants will gain practical insights into developing next-generation AI applications using Google's Gemini models, multimodal retrieval augmented generation RAG, and modern AI engineering techniques. Ladies and gentlemen, if your hands are not busy, please, with a show of the clap icon on the chat, give a round of applause as we welcome our speaker, Dr. Philip Obiora. Over to you, sir.
Thank you very much. Thank you for the warm welcome. So let me just quickly share my slide. Okay. Right. Can you see my slide? Can you see my slide? Hello?
It's loading. Yeah.
Okay,
Yeah,
it's
we can
loading.
hear you. Yes, we can see. We can see your slide. Please go ahead.
All right. Awesome. All right, so good evening, everyone, once again. Thank you for that introduction. So today we're going to explore how to build multimodal retrieval augmented generation systems using Gemini. So usually we have our standard RAG applications that are usually introduced as text-based systems. And usually we have take documents, extract text, create embeddings, and retrieve relevant chunks and pass them to the LLM model. But there is usually a problem in the sense that real-world information is not just text. Sometimes you can have information in tables, charts, diagrams, screenshots. So the conventional RAG systems would not be sufficient. And that's why today we're talking about the multimodal RAG systems. All right, so that's the essence of this webinar. So that today let's look at what we're going to learn today. By the end of today, we should be able to explain understand the text-only RAGs problem. All right, and then we understand the whole process of the RAG, the injection, embedding, retrieval system, and what happens in the multimodal RAG system. So we'll have to compare it with the standard text-to-text system. We'll do a text-to-image system and an image-to-image retrieval. All right, then we can also, if there's time, we process video with Gemini, retrieve relevant scenes and timestamp. And then we understand how these systems return grounded answers with page, image, and timestamp citations. I have a feeling that there will not be enough time, so I'll have everything covered so that even if we run out of time, you will have all the resources you need. So for this session, the primary material we're using is there is an article on Medium for this already. So if you scan this code, it takes you to directly to the article, and we have the skills, the Google Skills Lab. I don't know how many of us received the invitation to the Cloud Skill Labs. If you did, just can you show react if you received the invitation to Cloud Skill Labs. So Cloud Skill Labs allows you to take the lab. Let me just click on the Medium article. Can you still see my screen? What am I sharing? Is it the Medium article you're saying?
I can only see like the header of your browser. I don't know. You might want to reshare.
Okay,
Just
okay,
the Chrome tabs, yes.
okay. It seems it's just sharing only the okay. So all right, scan the QR code and go to the article so that you follow along. And then we have the lab to do, the Google Cloud Skills Lab, which is the primary material for this. Now, if you've already been invited, you will have access to this lab. So let me click on it. I don't know if I'm sharing a window or I'm sharing this. So what do you see now?
Okay, so we cannot see the screen. We can only see your Chrome tabs. So you might want to stop sharing and reshare so you can.
Okay.
Yes.
Okay, let me see. Okay. Okay, application windows. All right, so this is the lab we're going to do. If you go through the article, so what do you see now?
I'm still seeing your Chrome tab.
Okay. All right, so I join everybody to visit the lab. So just start the lab. Let me just introduce the lab before I go back to the slide. All right, so this is the lab we're going to be doing, and so if you signed up, if you have accounts already, you just need to just get started, and I'll come back to explain everything that's going on. So, but what is here is just checking progress. So when you click Start Lab, you're going to see this open Google Cloud Console. So open it with incognito window. So when you open it with incognito window, it will open another separate window, and then you're going to sign in. You're going to sign in. Yeah, Lawrence. Lawrence. Okay, so I think when you scan that QR code there, let me go back so that everybody can follow. So even if I don't have to visit this, you can all follow along. What are you seeing right now at the moment, please?
There are no screen being shared right now.
No screen being shared.
Yes.
Okay, so this is where we need to be. So I want the second I clicked on Open Google Cloud Console, right? It took me to this point where I need to go to the Google Cloud Console. All right, and then once you're here, the next thing you need to do is to go to Notebooks and go to Workbench, and then open the lab. So the lab is opening on Jupyter Notebook. Now you're going to see this notebook here, the Intro to Multimodal RAG. Yeah, so everything is right out here. So I'm going to go back to the slide. So while I'm explaining the slide, I'll be explaining all these whole concepts as we go through the slide. And so what you'll be doing on your own end will be to be running the cells and to understand what's going on. All right. So let me stop sharing and go back to the slide, and so that we can have a rundown of everything. So let me share the slide again. Oh, sorry. All right. Now, has anybody opened the article? Is anyone following the article already from the QR code? Is anyone following the article? So if you scan the QR code, it takes you to the article, this Medium article. Everything in the guide is there. So the first thing is you need to understand is the local ML or the usual LLM, large language models, have this static knowledge, are confined to a static boundary. Although these days we are talking about agentic and they are giving more tools to go online and then update themselves. All right, but what happens behind the scene is that the LLM is defined based on the limited training data it has at the time it was trained. So sometimes you see this LLM go into hallucinations and without returning the correct response you expected. And that's where the RAG solution comes in. So you now have external data integration. The use case of all this is you're dealing with your company data, you're having your your organization's file that you cannot share externally. So in this case, you need to query this, you need to understand this document, and you don't want it's not something you can get online. And this document is so complex that it has tables, graphs, and charts. The standard RAG flow, the standard conventional RAG documents would just is being introduced as a text-based document usually, and so usually you will have a database. When you submit, you're going to have a vector database where we already have documents, source documents, embeddings of stock documents that are indexed already in your vector database. And then when the user now makes a query, it forms part of the prompt. But before the prompt is sent to the LLM, there's a search being done for the relevant documents. And using the user query, there's a search is done on this vector database. And when the relevant documents are retrieved, is now added to the prompt to give the prompt more context before it is sent to the LLM. So all these now make up the prompt, and the LLM will now be able to respond with the correct output. So this is conventional RAG workflow. So, but when you now start having documents like this, so this, for instance, this kind of documents, this from the Google financial documents. So when you want to query this kind of documents with tables, so for instance, now we have a query that says, what are the earnings per share, class A, class B, and class C shares? All right, this simple question requires retrieving data that's locked inside, the tables, the charts. The text-only retriever would actually write a few things for you, and then say see table 3, but then the table is not there in the response. That's the problem with it. So if we have time to run the notes, you'll see this in action. And but when you now talk about the multimodality, it's looking at that document as an image, is able to understand, know where the page is. It retrieves the context. It tells you that class A is this, class B, class B. All right, so this is where the multimodal comes in with Gemini. So it's able to provide a grounded answer with page citation. So it's telling you exact page where it's getting this answer from, not just any random resource online. All right, so now what is the multimodal RAG? So you have your usual RAG convention, the retrieval augmented generation, but this, in this sense, is not just text alone. Yeah, it's not just text alone, but we are talking about images, tables, chart, videos, and it's going through injection where you have to load this PDF, right? Split it into chunks, different chunks, and then produce representation of these chunks. And so this is what happens behind the scene. These chunks are being stored as embeddings, right, in a vector database. So it's almost the same process, but in this case, we are looking at the different modes. We're looking at videos, we're looking at images, we're looking at unstructured, we're looking at all forms of data, right? So multimodal. And then retrieval, in the same case, it accepts text, images, and video query to do retrieval, and then it's able to generate grounded response. So this is what happens with the multimodal RAG. Now, this is the pipeline we are looking at here. So we first start with documents, documents that could include text, images, tables, graphs, charts, and then text is being extracted because this is multimodal. In the text only, you can just have maybe text only. But in this case, we're extracting text, we're extracting images, and this is being stored in it's being stored as embeddings. So you have the text embeddings, you have the image embeddings. All these are stored as a multimodal repository metadata. All right. Then when the user now makes a query, what happens is we do a search is being done, a text search is done, an image search is done. All right. When this search is done, the relevant results, when it gets the relevant results that has similarity index that's relevant to the context, it now builds the text context, view the image context, then it assembles the prompt. When this prompt is assembled, you now have your question, you have a context, and then this is passed to the Gemini. So Gemini now has very good your question and then well-formed context, and then is able to generate grounded answers with citation. So this is the multimodal pipeline with Gemini. This is the pipeline that is covered in this notebook. All right. Now, the comparison between the traditional and the multimodal, I've said this before, usually the text only, you have the documents, text extraction, chunking is done, it's divided into little chunks. And then you now have your embeddings, you now have your vector search, and then LLM tries to do the answering. But in this case, we have text and images and videos are considered at the same time. All right, so the documents here is not just text documents, PDF, images, and videos. There's a multimodal injection because we're ingesting both text, both images, both videos. There's text chunks, page images in chunks, and there are segments of these videos, as the case may be. And the embeddings is not just text embeddings. It's not just, there is multimodal embeddings for those, for text, for images, separate embeddings, and metadata for each of these different modes. All right. And then the search is a cross-modal retrieval. It's checking context from both the text, the images to get different segments to get an appropriate context that will be now passed to Gemini reasoning. So at the end of the day, Gemini reasoning will be able to give you grounded answers with good citation. So a rich document would have charts, graph, tables, diagrams, and then Gemini has the capability of interpreting PDF, understanding the layout, and it can scale. It can even scale up to 1,000 pages, and so it can now give you grounded reports, even if it's image, even if it's multimodal. All right, and why this matters, it enables source tracing. You can trace the source, and it can also support citations. All right, and it can also improve multimodality filtering. All right, so once we move to the code, I mean, if I explain all this now, once we move to the code, you'll start seeing that there is a utility function. There's a function written already that gets the document's metadata. This function produces two data frames, the text metadata data frame and the image. So this is how it does the multimodality indexing. So it's not just considering text at once, it's doing the image metadata all at once. And then this will be able to access the chunk text at the same time, the image description, page number, the image page number, the chunk number, the image part, the embedding for the image, and a separate embeddings for text. So you can do vectors, a vector similarity search for the text and a separate vector image similarity search. All right, so you'll be able to now know which page does this content come from. You know, you'll be able to see the visual evidence. Is there a picture that substantiates this claim of this response the LLM is giving you? All right, and then can you trace the answer back to this source? All right, and then what metadata could be needed for the production of the application? So you see all this. This is what this function gives you, and yeah, so this is how the multimodality happens. So like we said before, the text-to-text retrieval would just wouldn't give you the table as needed. Yeah, but multimodality is able to look at this, do a semantic similarity match, right? And then return the relevant content based on your search. All right, so that's with text to text. And then this fails, text to text will fail in a number of things when it comes to rich documents, because charts has no extractable text, right? So a bar chart contains visual encoding, and you might not be able to extract it. So you have scan pages that can produce nothing. Tables are not, extraction may be difficult regarding tables, and then the layout too is an issue. All right, so the diagrams are entirely invisible to the text-to-text extraction mode. All right, so that's where the multimodality comes in. So you now have the text-to-image retrieval, where the query is text, and then the retrieved evidence is an image. All right, so the modalities don't need to match. So where you can just, the same question, but it's giving you an image. All right, still an augmented retrieval generation. Yeah, so this is why multimodality works. So with that, you can do text to text, text to image, image to image, and then text to image. All right, so all this could be done. And more importantly, you can go in depth to do comparative reasoning. And so now look at this prompt. These are these prompts. You're answering only from supplied evidence. You're telling, so the task is a prompt. You're answering only from supplied evidence. Compare, retrieve items, and answer the question. So the requirement is distinguish information visible in image from text. Do not invent any missing values. Cite the source file and page for each major claim. So this is how your prompts might be, because you want to get the right information with the right context and the right source. You don't want it to go online and you don't want it to hallucinate. All right, so when you have separate modalities, this prevents text evidence from being attributed to the chat. All right, and then there is no invented values. This prevents hallucination. It's able to cite the source and page because there are different metadata for each of these. For the image, for the text, it's able to have image description embeddings, in its own vector database. And then it can admit, if it's not able to find that information, it can admit that that information is missing. All right, so usually our end-to-end multimodal RAG augmented generation system would be in this form. So we'll be able to write a query. So let's say this is our query. What do the reports show about this? So what happens? We have retrieved the text, get the top 10 relevant search based on search similarity, cosine similarity. We retrieve the relevant images, get the top 3. And then this top 3, both the text and images, is used to construct the context. All right. And then, so we combine this text and image context into a structured object. All right. And then this will now be passed to Gemini. So you can see we have the text result, the image results. And then when we are passing it to Gemini, we are passing the query, the text, and the images. So this will now form the context that you're asking Gemini. So it's not just your query that you're asking. So you can see where you have the retrieval augmented generation, where it comes in. And then this will now be passed to Gemini, and then you now have a dedicated response with citations. You can tell the page source, the image that goes with it. And so this is a typical, this is how you find the code to do that. All right, so now let's proceed. So we can go further to do this with videos. So in this case, you can upload a file. We could have inline videos for smaller requests. You can also look at the cloud storage URI for hosted videos. So these are supported input methods for the video. You can actually upload the file. You can have an inline video of base 64 encoded. You can have a YouTube URL. So this is what it supports. And so video segmentation and indexing. So this for the video part. It's just almost something very similar. You have an input, you have it segmented in chunks. Time-based segmentation is done, just like chunks. And then you now have transcripts, visual summary, and timestamps. So this is, you can see, an extra layer which is done in the images. And they now have the embeddings for all these transcript, visual summaries, and timestamps, multimodal embeddings. And then before it's stored in the vector database. And then when a query is done, we retrieve relevant segments, and then this will be used to construct the context. And then with that, Gemini answers using the selected clips, because you're giving, it has the full context, it has all the context it needs, the multimodal context it needs to give you the correct answer. All right, so we've seen that we have the PDF document, video files, standalone images. These are all that could be done when we're talking about the multimodal retrieval across documents and videos. So documents, you have the text are being broken into chunks, right? And then in videos, you have time segments, you have time segmented transcripts, virtual summaries. Image, you have the image description, you have the source file and metadata. So all these are being splitted. You have embeddings for these different features. All right. So this is what makes it rich, makes the context very rich, because you see there's even equation and diagrams for images for the PDF. There's charts and tables and images. So it's going to create embeddings for all this. And then, so when you now have your query, you can find evidence from, you can ask it at the same time. So in Gemini, you can ask it, find evidence from both PDF and video. And then it will do what? It will retrieve from the text, retrieve from the images, get from the video, retrieve different segments, relevant segments from the video. And then, so what you're asking Gemini is, we pass the query, we pass the text, the images, and then the video segments. And then it will now be able to reason the correct response and give you grounded response with citation. Yeah, so this is grounded response and citation. So you have your page citation, your image citation. You can also have your timestamp citation. So yeah. Now, usually a good, after now, we're going to be jumping into the labs hands-on, so we can run it quickly before the time goes. All right, so a good evaluation should have, you should be looking at retrieval quality. Was the page correct? Is the page, is the correct image returned, all right? So was the relevant evidence, was it one of the top scores? So you are looking at retrieval quality, the answer quality, is the response correct? Is every claim supported by the retrieved evidence? This is what you should be asking your LLM. For each response you get from your LLM, you're looking at the retrieval quality, the answer quality. All right. Does it admit, does your large language model admit when evidence is missing? All right. So that's where we're talking about RAG. We're talking about multimodality RAG, so does the response use visual evidence correctly? So these are how you evaluate the response of these LLMs. All right. You're also looking at citation quality, questions to ask. Does the citation point to the correct document? So human in the loop, you check the citation accuracy, you check the page, does it match the timestamp? So all this is how we evaluate yes, all this is how we evaluate the LLM. So I think right now we need to go into the lab, and before we now, let's dive into the lab. So I would click here now and then go back to share this, again. So let me share the lab as it's loading. Stop sharing. Okay, so where we share. Let me share this again. Yes. Oh, I don't think this is what I want to share. So when you go to the lab, we're going to open this in incognito window. I need to share this again. Oh, sorry. Let me just share the new window is opened again. Okay, I think just a minute, please. Okay, what I'll do now is I've shown you the lab. So I have this on GitHub already because of time, so that we'll not be waiting for output to generate and content to load. So what are you seeing now, please?
So I can see your GitHub.
Very good, very good. So this is the lab on GitHub. Just the same thing. So on my GitHub, I have an adaptation that works on Colab. In case you want to run this on Colab yourself, but this is the utility file it uses here. These utility files have been written to get image embeddings, to get the text overlapping chunks.
So it seems like the font is small.
Okay. Is it bigger now? How is it now?
Oh, it's better now.
Okay. All right. So let me just go back again. So now, once you're here, this is the lab itself, the same lab. This is it. Yes, this. Now, all these are concepts I already explained. And so what happens here is we install the generative AI standard development kits from Python and other dependencies. It's quiet to tell you not to be verbose. And it's a library that is used to interact with PDF. So we install the necessary libraries, and we need to restart the kernel, we initiate our project. So when you go to your console, you're gonna have your project ID. So set that up. So on your own, if you go to the Colab, you could just replace your project ID with this and run it. Then you're gonna have next, of course, import the libraries that we need. The model here we are using is Gemini model 3.1 flashlights. So here we are downloading the utility file we need. So in the lab, directly on the lab, what happens is just this file you see, but when you now download this, it takes you to the utility file I showed you earlier with those functions. So this is where it's downloaded here. And then, so like I said, what happens is we are building a metadata of containing text and images at the same time. All right, that image I showed you was from Google's financial documents, operations, business operations and management reports, right? So we import the this function that we need, because we need to be able to get document metadata from the utilities file I showed you earlier. That file has this get document metadata, which is very important. It does two things at the same time. So if you go back to the, if we go back to the pipeline, if you go back to the pipeline, you would see, yes, the pipeline is here, right? So you could see this is where it creates extract text and it gets extract the images at the same time. So this is what happens here before it creates the embeddings. The function does this, it does injection, creates the embeddings for us, and then it's stored in the multimodal metadata repository. Let me go back again. Where are we? Okay, yes. So yes. So now what happens here is we load the document we want. Yeah, so we specify the parts we want the document to go to. We specify the description, image description prompt. This is a prompt that generates the description for each image. All right, so we'll write that prompt, explain what's going on the image. So for every image you encounter in that page, in any page, extract the elements of the table, get the GIF is a graph, explain what's happening on the graph. So there's a prompt dedicated to each image and each graph. All right. So remember so it gets all this, it gives you a data frame for the text, a data frame for the image. All right, see, this is where we pass the model, the path to the folder. We tell it that you should go to save it in the images directory. Give it the description to the prompt, and then tell it to give us an embedding size of 1480, right? So these are like features, in numbers, vector embeddings, So it does this, it does the retrieval, loads for each page, it's processing each page, and then completed processing. And then, so when we now start inspecting the text embedding page, so we can see it has a file name, the page number, the text, the source of it. So you can see how the embedding each is for that page. The chunk number, it breaks it into chunks. The chunk text and the text embedding chunk. All right. Remember, this size is, we're looking at 1,408 size of this. So you're just seeing only these ones I was saying here because of the space. All right. So you can see, you can also inspect the data frame for the image. And you can see there is also the image part, image description is being given. There is the embeddings for the images only, the text embeddings for the image description. Now, when you write a query, when we do a search, it's not just searching the text only. So for text only, just got what happens if you do text only. It just takes the query and does a similarity search for the query. It checks the text metadata and then checks the text embedding chunk, gets the top three, all right? And then, of course, it chunks the text. So what happens is it gives you look at the match text it has retrieved. This is a similarity score. And so the query is, I need details for basic and diluted income, class A, class B, and class C. But at the end of the day, what happens is it is telling us that it wrote, of course, it told our class A, which is able to find information, but then look at where the problem happens. It says the following tables set for the computation, but the table is not there. So that's the problem with text-only retrieval. All right, so yeah, so that's what we've seen there right now. right? So, and so in this case, if it's not able to find a response, it's able to say not available in the context. So it's not able to, it has returned the top three, which it knows has information, and it knows that it's not available. The context, whatever you're asking is exhausted it already. And yeah, so, but when we now start doing the, using Gemini to do the image to text query, so these are a query, still text, is looking for class A, class B, and class C share of the Google. And then is able to get the image from the query. It's looking at the text image data, metadata. It's also looking at the image metadata data frame. It takes the query, and then the text, and the image description is also passed, right, as a parameter. All right, so, and then the embedding side. So all this is able to get, you can now see with this text now, it's able to return not just text, able to return this image of class A, class B shares of Google. So it's returning exactly what we expected. And then we can also decide to return this as a JSON file. All right, so you can return as a JSON file. All right, so, and then, so you have a detailed text description, you have a detailed explanation. You can also do an image search, image to image, where you give it an image, and then your output is where it gives you exactly where it matches the document. All right, so it gives you images with the similar results. So that's what happens with image search. All right, so comparative reasoning is done here. This is more in-depth. So you're looking at show me all graphs that shows the Google Class A cumulative 5-year total return. I mean, this is about the query itself. The information is in a graph. This would definitely fail with a text-to-text retrieval. Right, so yeah, so this is all you get when you do the multimodal retrieval augmented generation. So we've seen all this. So putting all this together, we've seen the different aspects of it. When we put all these things together, retrieve relevant chunks, retrieve relevant images, create the text content and text images. All right, then we're able to get a more grounded reasoning with context. So let me go back to the slide so we can round up. You can see that time is almost not on our side again. So let me go back to the slides so that we can quickly round up before and have time for questions. Okay. All right, are we back to the slide?
Yes, we are.
All right, good. So the key takeaway is that rich documents are more than extracted text. All right, so you have charts, graphs, diagrams, and with multimodal embeddings, you have ability to do cross-modal retrieval. You know, you can query an image, do an image search. So in this case, multimodality does not matter in the embedding space. It would definitely give you the results. And yeah, so Gemini reasons, right? Gemini is able to give you grounded answers with text citations. All right, so and the essence of all this is have a trustworthy system, so you can actually know where the source is coming from. You can actually trace it back to the specific page, and so everything is traceable. The source is traceable. Yeah, so you have a trustworthy system. You have grounded reasoning with evidence, and yeah, so this is why we need the multimodality in retrieval augmented generation. So thank you for listening, and this question time. If you have any question right now. Yeah, so this is a QR code for feedback if you want to give feedback, and then if you want us to connect on LinkedIn. Yeah, so questions right now. I think that's all. Thank you very much.
Thank you so much, sir. We have a hand raised. Okay, Engineer Lawrence, over to you, sir.
Okay. Can you hear me?
Yeah.
So
Yes,
one
I can
question.
hear you.
There are some of us. Let me talk for myself. I'm not a programmer. So the first question I want to understand is, do I need to like write codes for this? That's the first question. The second question is, okay, this is Gemini. I assume my company is using like Microsoft Teams, right? Is it possible for me to kind of use this for my work? Because I think it's very, very important, because you might have like a folder that is a bunch of all the modes, in fact, audio mode, or video mode, or text mode, or PDF, or scan copy of diagrams and stuff like that. So what I'm getting from this, which is very important, that is able to kind of harness, go through all the modes and be able to kind of extract information across different modes. So if I'm now, what my question now is, like, if I'm now using like another platform, maybe, so isn't it like API that, so that's the question. So the first one is, do I need to be a programmer? Because I see a lot of things that looks like code that scares people like me, then the second one is, how do I use it out? Like this Gemini, I know Gemini is from Google. So how do I kind of integrate in some other things? Thank you.
All right. So usually of course, the Gemini model in itself is multimodal, right? But then when you're talking of retrieval augmented generation, you want to narrow it down to your company data. You don't want to put this online. All right. It's not online because it's just your company report, financial report. It's not anywhere online, right? So even if you ask, you cannot even use an LLM you cannot use an external LLM to say, you cannot query it with an external LLM, right? So you want an in-house tool. This is where it comes in. So you will need to kind of have a RAG system, right, that queries that document, in-house document, and is able to give you grounded responses. This is the page, this is the image responsible for this is the graph that does this, is able to compare different resources.
All right. Thank you so much, Dr. Philip. Do we have any other question quickly with a raise of hand? Before, okay, Olalekan, quickly over to you. You can ask your question.
All right. Good evening, sir. Thanks so much for the teaching. So I would like to ask that, is it possible to get the slide record of today's teaching? Thank you.
Of course, this there'll be a recording of this. This is recorded already. So I think at the end of the day, the organizers will be able to share the source of all this, both the article and the GitHub, all the resources regarding this. All right.
Yes. So this will be on the KodeHauz YouTube channel, and you'll be able to get access to it. So you just look out on our socials for more details on that. Thank you so much, sir. All right, so that will be all on the questions. Thank you so much, Dr. Philip. It's so good to have you. You can connect to him on LinkedIn. If you cannot scan the QR code, the link is in the chat. You can also give feedback. All right, so we'll now be moving, the session is rounding up, and we want to tell everyone that KodeHauz is 10 years, and we are celebrating this in a grand style. And you really don't want to miss the next webinar session too. So next week, Saturday, so this is a 10-week webinar series. We're going to be having this every week till October 3rd, 2026. So every Saturday, come to learn, come and have the needed knowledge. All right. Engineer Lawrence, your hand is still raised. I don't know if you have something to say quickly.
Yeah, quickly. Look at the chat. Someone dropped a question. Fortune pressures.
Oh, okay. Thank you. Can I use this with Gamma? I have a question. Okay, Fortune, your hand is raised. You can. Is that all your question?
Yes, I
All
wanted
right.
to ask, I want to say thank you for the lecture on multimodal RAG with Gemini. I wanted to ask if I could use it with Gemma. It is restricted to Gemini, or I can extend and use with Gemma.
Yeah, I mean, Gamma is one of the it's still under the family of the multimodal stores, and but there is emphasis on edge computing, lightweight. All right, so you can actually do that with it.
Okay, I do get you. Thank you.
All right. Thank you, sir. Yes. So right about now, I would like to, invite, or should I say, call on two special people in our midst. The first person is the managing director of KodeHauz, and they'll just say hi to us. And yeah, so I'll be calling on Engineer Lawrence Akubwe. Hi, sir. It's so good to have
Okay, let's
you
the other kind of
join.
face. There's kind of noise in the region
Oh, okay, that's all right. All right. So the second person I'll be calling is the CEO and founder of KodeHauz. Like I said earlier, KodeHauz is 10. It's a big one for the company. And I'll be calling engineer Aniebet Udo. Hi, sir. Good evening.
Okay, good evening. I hope you can hear me.
Yes, I can hear you, sir.
Okay. Thank you very much, Philip, for coming out here to talk to us about multimodal. You know, I've been teaching about RAG in the last two cohorts of Code Camp. And of course, when we do RAG, we do basic RAG, which is the text-based one. So I was really interested in your topic. And I have to say that I'm not disappointed at all. Thank you very much. A lot of interesting, insights into using Gemini, using the multi-modality of Gemini for us to be able to do RAG. Yeah, what you have identified is a real problem. Now, when you start building RAG for enterprise, in real world situations, you actually find where the text-based system is grossly inadequate. So thank you very much. I had a few questions myself. I think one of the questions I wanted to ask, and which I might still ask, is it only Gemini that we can use this for? Multi-modality, there are a lot of different frontier models apart from Gemini and the GPTs of OpenAI and all the big guys. There are also the models from the East, the Quens and so on. Can we use any other model that has multi-modality, or is it just only Gemini? And I'm interested in looking at your code base and your article. I'll take some time to look at that. But the question is this something that can be adapted with other models, or is it just only Gemini? So I think I'll just leave that question for you to answer maybe when you round up. But aside from that, thank you very much. This is an insightful one, and I hope we'll have more opportunity for you to come and train. I know we have a bunch of people here who are AI developers. Apart from Lawrence mentioned there's also a bunch of people who are not programmers or developers. And I guess his question was more like, can I do this without having to write code? Can I still configure Gemini maybe on the Google console for it to be able to take rich data, rich content, and still use it in that kind of RAG system? I think it's in the context of something like custom GPT, which is more of a user-facing thing where you can upload these things and then you can still query the agent or the LLM on that information that you have uploaded, even though it's rich. I think that's what Lawrence was asking about, whether he can access that same capability without having to write code. So I guess that's another question for you. So, but overall, I think those are the two main areas. There are a lot of people on this webinar who are more or less AI developers, but there are also a lot of other people who are users of AI tools, and I think it's relevant to them. So I want to say thank you for bringing this topic up and showing us, and I really appreciate it. Thank you.
All right. Should I answer the questions now?
Yes, please.
All right. Okay, let me start from the last one. So, Lawrence have asked that before. So there are, yeah, let's say people that don't know how to code at all, because there are usually tools these days for building RAG applications, right? And one of them is there's the Vertex AI agentic platform that's, but you still need to understand some things. There's a RAG flow tool that's, there are some tools that allow you to do drag and drop, and then but customize your own RAG application. So that's what you'll be looking out for. But behind the scene, they will follow this pipeline, right? They will have this almost the same pipeline. You upload it, you will able to upload your files, then you can, maybe you have a document, something that will be able to pass the document, right? Analyze the PDF, and then they probably now choose an embedded model, right? Then connect to a vector database. So you have this pipeline where you can do drag and drop to build, customize your own. If you don't want to do if you're the no code type, right? There's a tool, that's what you're looking out for. There's Rackflow, there are other tools anyway, which if you do research, you'll be able to see those tools. And then but they will follow the pipeline of that sequence. And then the other question, what's the first question again?
Can we use other models apart from?
Okay, yes. Of course, yeah, other models could be used. I mean, it's not just Gemini. I mean, there are other models could be used even outside Gemini. Even the Anthropic models, even the OpenAI models. Usually you have your Gamma 4, like someone asked before, is also OpenAI. The Quen, the Llama, right? So any of these multimodal models can be adapted to do the same thing. But you just have to know what kind of probably vector store do they need, all right? And but then yeah, you can actually use other models to do the same thing, all right? Yeah. But what I've just explained is the Google the pipeline with on Region Gemini, right? People do run
Okay,
chain
thank you.
and other frameworks. Yeah. All right.
Okay, thank you, sir. There are two more questions in the chat, so I'll just quickly read the two, then we round up this session. So the first one is the old code available on your GitHub? And the second one is, does offline models work?
So
Did you get that, sir?
no, come again, please.
Okay, so the first question is the old code available on your GitHub? So I think the person is speaking to what you showed us during this session. That is everything needed on the GitHub. And the second question is, does offline models work? offline models?
Okay, yes. So, I mean, this code now is available on my GitHub. I don't know if someone can paste the link there. The code is there on GitHub. But if you want to actually run this, because you need the GCP account, right? You need to do this on the Google Cloud platform. Even if you're not doing it on the Google Cloud platform, you want to use Colab, you need that account. You need the Google Cloud platform. You need your project ID and your project number. And then sometimes you need billings, right? You might need to do, there are billings tied to this. So you need that to run this on the Google Cloud platform to run the code actually. Yeah, so but the code is there and you can actually, if you get stuck, you can actually copy and paste anything from there. Then, of course, RAG applications are usually, so if you have your model that is open source that you can run on your machine, right? You have the GPU and the enough GPU for that, or you have enough memory to process the data required. You can actually have your model offline and then have the same pipeline that would do the embeddings for the images. So you can have this whole thing offline, have a vector database offline, and do your retrieval. So you can have your custom interface. In fact, your own company GPT, so to speak, because you want to be able to upload your company data without going offline and be able to get grounded sources from it, telling you page number with the correct response. So you can work offline, yes.
Okay, thank you so much for that, sir. All right, so everyone, we are now at the end of this session. Thank you so much for your time. Thank you for the resources shared. Like we said, you can connect with him on LinkedIn. The link is in the chat. Okay, Engineer Lawrence, your hand is raised. Please go ahead, sir, before we talk about the next webinar. Over to you, sir.
Okay, so yeah, I was in a noisy place when I was called. I had to leave the place. I was I will start my this comments with a question. Philip, please, before I continue, just do me one favor. For the poor masses, ordinary man on the street, what is RAG?
All right, so retrieval, it's basically retrieval augmented generation. All right, so retrieval in this sense is you have your usual prompts, you have your usually go to LLM, you write who is the president of Nigeria, all right, or rather how much do I need to, how much, okay, let's look for a financial document right now. Okay, just simple, you ask a question, right? That's your query. Now, the LLM can decide to just go online, do a search. There's a tool, just search online, right? It retrieves information, right? But it's online. It's actually retrieval. But then adds it to the prompt. It just goes online and then looks for information and then returns what it thinks that is the answer. This normal LLM, right? But in this case, we're talking about a retrieval augmented generation. So you do a query, it's goes to your data, it goes to the vector database, right? It goes to a storage where you've already stored chunks of data, right? And where you have those files, it's already converted to numbers, right? So that you can easily do a search. So that your query, it gets more information and adds to that query. Now, it retrieves more information from from your personalized vector store, right? Or from your storage, localized storage, then adds it to your prompt. You see, it has augmented your query. And then the next stage is what? The generating response. So your query is not just only the query you wrote. It has added another layer to your query. That's the augmentation. Then the generation is the LLM now has more context with your question to now give you a grounded response. That's where the generation comes in. So it's now retrieval augmented generation. So you have your prompt, extra layer of context added to that question, and then it's given to the LLM to give you more correct response, more grounded response. That's the RAG.
Now I feel like I've participated in webinar. At least I can go with something like I can explain this, even if you wake me up from sleep. I can explain it because, man, like when I was seeing the codes and everything, like, am I supposed to be here? But it's fine. You see, I think there are a lot of constituencies I'm representing here, but they might not be able to talk. But I think I have been able to represent them well because you have to carry us, the poor masses, along in this whole thing. At least I have gained something. Like the way you explained it. In fact, this is the webinar for me. I am very happy that I got something. I don't like participating, and I like, what did I even learn from this thing? So that's fine. So thank you very much, everyone. So I'm going to make so KodeHauz is actually 10. The KodeHauz, we have 3 things that we do, right? We do training and like everything that has to do with developing human beings. So we call it training and mentorship, right? So that's one thing we do. The second thing we do is research, right? So forget about the why sound. We have very technical people here, and everybody's on the call and everything that even doing research on AI related stuff. Then the third arm of KodeHauz is developing products. So you can see the 3 again. Let me repeat again: training, mentorship, research, and then development. When you talk about development, 3 things: mobile application, web application, and then embedded systems. Like we do hardware as well. So we do research in all those 3 areas and development as well. So just to give you a context about KodeHauz, we are not very well, like it's not one of those stuff that popular, but we have been there for 10 years, right? In terms of human development, we have been running CodeCamp consistently for 6 years right now. If you go to YouTube, you're going to see like 1,500 videos of training content. In fact, we are rounding off the 6th edition. This is the 6th year we are running CodeCamp. It's a free training program. We run it once every year, right? From there, we have like what we call in fact, our mantra in that first point of KodeHauz, first activity, is to build skill economy, because there is, of course, there are different kinds of economy, but we believe that human beings are equally like an economic ecosystem. So KodeHauz, we want to be recognized. So since 2021 that we started CodeCamp, so far we have had more than 18,000 people that have signed up for the program. Of course, the sign up is not, of course, they started the program, right? But we ensure that you actually take it to the end. Right now, we're actually at the penultimate stage, stage 7. After stage 7, we'll do project, which is stage 8 for this year. So you can't actually enter this year, but keep your, if you are really interested, keep your ears on the ground. We run it just once every year. Why is once every year is not? Because when we end the program, people migrate into internship. And we have 2 layers of internship. We have unpaid internship where you work without pay. Because let me explain why we do that. Because a lot of training are going on now, 3MTT, ALX, XDL. So if you finish any training, you're just like one of those people that have been trained in Nigeria. So what is the difference between you and somebody that is like doing other training? So we added that layer because if you finish training without internship, you understand. So in that internship, you do it like a job. You're going to do an interview, we'll give you offer letter, and the only thing is that we are not paying, right? So that you can go for other interviews, beating your chest that have actually worked. That's the idea. Okay, so you have that working environment, give you email and everything. So after that, those that succeed will now go to the paid internship, right? Where we put you in real life projects that customer clients are working on. So that's it. That's why we cannot run like code camp twice in a year. So it is the same people that move from one stage to another stage. So when it comes to research, I've talked about, so we've been doing this for a while. So when it comes to research, we are very strong in both hardware and software. Okay. So just last year here, KodeHauz won the second best innovation in Nigerian Society of Engineers. We had a couple of innovations that we built, like smart meter with embedded payment gateways and stuff like that. We're currently, into building automations, making buildings smart and all those things. There are a lot of, we have currently doing research on smart table box. We are doing research on, I don't want to go into all those things, so not to bore you. Then the third arm now is just uh this one, everybody knows that you bring software, we build it for you. Bring enterprise version, we'll build it for you. So now this is the 10th year of KodeHauz. So let me round up like this. We are going to be celebrating it by having 10 webinar series. Okay, they are going to announce the second one. So if you don't really feel that you are fitted into this first one, don't worry, there are more for you. Okay. We are going to be talking about robust ecosystem, that building a robust ecosystem. I think they are going to announce it. I don't have the full this thing of my this. I'm going to hand over scaling business with AI-driven research inside the future proof professional, staying healthy, productive. There's even a health aspect of it, AI technology, international sales. Okay, for those that are in present in sales, driving through the digital transformation, government as a catalyst. There's going to be a government building a technology pipeline that concerns, building people and all that. So there are a lot of, I can't read all of them now. I can't remember all of them, but these are few. So it's going to be, so you can actually, if we are going to do it, because it's 10th anniversary, we are going to have 10 webinar series. So this is the first one. Next one is going to be on, okay, I think I'm going to allow them to talk about it. So it's going to be the same time next week, just continuous like that, 10 times until we're going to now have the grant. For those that want to come, it's going to be in Eket. We are actually located at Eket, where we'll be doing like a conference on the 10th. So the idea is October is the 10th month, and the 10th of October is a Saturday. So it's 10-10, right? So that's the whole thing. So we're actually going to be exhibiting our technology products that day. All the research I just mentioned. So there's going to be exhibition of technology products, and more than 90% of them are AI driven. Because KodeHauz, I'm going to end like this, KodeHauz want to strategically and intentionally move to becoming an AI driven company. And that's why I won't be that's why you people won't be surprised if you hear we are partnering with Philip in one or two projects using. So, Philip, we are going to be knocking on your door. You understand? We want Nigerians to compete in this whole new wave. That's the thing. We are not dull. We are very, very smart people. I know, yes, the condition is there, and that's what KodeHauz stands for. No matter how hard it is, look at us doing Code Camp for 6 years, without any big sponsor and everything. We know that we can win against all odds. We'll be able to play in this whole AI new wave. So thank you very much. I'll hand over to Mole again to now talk about the next edition. Thank you.
Thank you so much, sir. So good to hear you. Just like he has said, I'll be speaking now on the next webinar, which will be taking place on the 8th of August 2026, exactly next Saturday. So the next Saturday. So just prepare. It's still same link, same venue, same. The only different thing is that for next webinar, we'll be having the topic building a robust tech destination in Nigeria. And the case study we'll be using is Akwa Ibom State. So please come early. We start exactly 7. And yes, so that will be all from us today. I know you've had a very good time here. All right, sir, you want to say something?
Yeah. So before we go, this events, this webinar right now is done in partnership with GGG Cloud Port Harcourt, and we wrote to Google to give us credits, Google Cloud Skill Boost credit. So some people have been sent Unfortunately, I requested for 50. I didn't know that the slots would be more than 50. So I think we have over 50 people that have been given these credits already. So if you've gotten the email, you have the email, activate your credit, and then try and complete the lab, right? Try and complete that lab on the article or wherever you saw it. Complete that lab. You can even do the search on this and it take you to the lab. Complete the lab. Google is actually monitoring your activity, right? Based on whether from this webinar, how many people have completed the labs, how many people did that, right? So please let's try and copy so that next time when we request for these credits, they will just oblige without thinking about it. Thank you. Hello?
Thank you very much for that. Definitely we'll have a lot of people who will come in for that. So please, we will need to get the information from you so that we can distribute. So we're going to do that. Definitely a lot of people are going to sign up. And I know a lot of people, at least I know people, we have 3 AI classes in CodeCamp running currently. So we might even look at how we can bring, because right now we are at what we call the project phase of CodeCamp. Project phase is when the training is done and they are about to start building real world projects. So we might actually discuss with you to see how, we have a class on AI for developers. That's where the RAG is really, being used. We also have a class on machine learning core where they are training, models. And then we have a class on AI for AI applications and tools. So these three, we'll see how we can bring them in and maybe they can make use of the credits that we have given so that they'll be able to build something as part of our project phase. So thank you very much for that. Okay, so it looks like moderator is offline. So well, we don't have anything else, and we are out of time. So we'll come to the end of this particular first edition of our webinar series for the 10th anniversary of KodeHauz. I want to really thank you again, Philip, for coming up, and not just coming up, but really giving us this very insightful class. It's a very good one. I'm still going to say it again. So thank you for the lecture. Thank you for the opportunity to look at multimodal brag and how we can improve, the products that we build. Definitely you hear from us again. And definitely, like Lawrence has said, we would like to collaborate with you on building products because Nigerians, Africans can do it and want to show that we can do it. So I really appreciate. And on behalf of KodeHauz, on behalf of CodeCamp, and everyone else who has been in this webinar, we say thank you and hope to see you again very soon. And we also say thank you to GDG for the support. Thank you. Good night, everyone.
Good night.
Right.
Thanks, everyone. Bye.